So let's look at the question. The question says a block of 20 kilograms is pulled upwards by a force F along a plane inclined 30 degrees to the horizontal. This one is a degree here, right? Not 300, it's 30 degrees to the horizontal. It accelerates along the inclined plane at 2 meters per second square. The surface of the incline exerts a frictional force on the block. There's friction on the block, and they don't tell you how much. There is acceleration on the block, and they don't tell you how much. Okay? So for this question, because we don't have the picture, we have to get an idea. Therefore, we are going to draw the picture of what is going here, to have an idea. We have an inclined surface. That is my inclined surface. There is a block on the surface. There is a block on the surface. And then let's see the question once more to read, okay? To start adding things. A block of mass 20 kilograms is pulled upward. So this is a force acting on that block upward parallel to the surface. This is the applied force. You have that the object has a mass of 20 kilograms. We know that the surface have an angle of 30 degrees. This angle here is 30 degrees to the horizontal. And then you have the acceleration. So the object is moving upward. It's moving in that direction. I'm going to write moving. And the acceleration is equal to 2 meters per second square. That is given to us. Here is all the data. There's also friction. I'm not going to write friction there, because we don't know the friction. We just know there is friction. Okay? So draw a diagram showing all the forces acting on the block. Force diagram, the same bracket, force diagram, as it moves up the incline. Also draw a free body diagram for the block. Represent the force on the Cartesian plane and resolve the gravitational force into components. In this question, I set up this question, so I wanted you to do that way. But remember, in a free body diagram, the axes are not part of the free body diagram. Okay, so the first one, they want the force diagram. So we have the block. That is my block, and all the force acting on the block. From there we have now, let's see. We have weight, which is straight down. Now, as I were yesterday working with other learners, I saw I don't know why they attempt to turn the force to the left. There is straight down. So in your book, you make sure you have the ruler straight down perpendicular to the page. It means you take your ruler and you make sure, let me place here the ruler so you get what I'm saying. You make sure this ruler is perpendicular to your book. So you can use the size of the book on top to make the line straight down. Because I don't know why every time I see the learners trying to turn that line towards the left. And it must be straight down. If you do to the left, you lose the mark. Second, you must have now friction. So friction, if the object is moving up the incline, it must be down the incline. Here on the drawing, it must be in that direction. Is that correct? So when you come here, you make sure you draw it in that direction. Look here. That is the frictional force. There we go. That is my friction. Parallel to the surface. And the normal must be perpendicular to the surface. And therefore, also perpendicular to the friction, because the friction is parallel to the surface. So here, the normal must be perpendicular to the surface. In other words, it must be in that direction. That is normal force. What force is missing here? The applied force. So let's have the applied force. I'm running out of colors. The applied force must be parallel to the surface, but pointing upward. This one here is the applied force. If this was for exam, you will get 1 mark per force. So it will be 1, 2, 3, and 4. Now they ask to also do the, sorry about that one, let's take this one, move it a little bit down. They also ask for the free body diagram. Now in this question, intentionally, I ask you to do the axis, but this is not part of the free body diagram. I ask you because you must learn how to use those axes. So the x-axis must be parallel to the surface, and if I do it parallel to the surface, it will be with an angle. It will be more or less, let's say, there. Are you with me? That is like that one was the x-axis. Can you see that one? That is my x-axis. How do you draw the y-axis? Perpendicular to the x. That is mathematics. So you come here and you draw your y-axis perpendicular to the x. This one is y-axis. This one is x-axis. I'm going to take the direction in which the object is moving as positive, will be up the incline. Now all those forces I draw there, I'm going to draw it once more on the axis. Okay, so I'm coming here and I say frictional force is pointing backward, so this one is frictional force, right parallel to the axis. Normal force perpendicular to the surface, so it must be right on the y-axis. This one is normal force. You make sure this one make an angle of 90 degrees there. You make sure of that one, otherwise it's wrong. What are the forces here? The applied force pointing up the incline. This one is the applied force. And what is missing there? Weight. Weight is pointing down. Once more, you get the ruler and you make sure it's straight down. This one is my weight. They are all my forces. Now, intentionally in this question, I ask you to include the components. It's not part of the free body diagram. I ask you intentionally because I want to use it. So when this one comes to the y-axis, you will get here is going to be this one here. So this one will be weight in the y-axis. And if the angle, now this one is something important also. This here is the angle of the surface. Is that correct? Which was 30 degrees. That angle is this angle here. That one is 30 degrees. Okay? So saying that, the adjacent side here is the weight in the y-axis. Did you understand? Therefore, if you come here and you want to calculate the component in y, you have that the component in the y-axis is equal to weight multiplied by cosine of theta, because it's the adjacent side. This one is weight cosine of theta, which in this case is 30 degrees. How do you calculate weight? Mass multiplied by acceleration. So this one is equal to mass acceleration cosine of 30 degrees. That is how to calculate the weight in the y-axis, or perpendicular component of weight is also called like that. What are the components I have here? The horizontal component. You go to the x-axis like this. Here, right there is this one, is the weight in the x-axis. That one, you can also move it here to the side of the triangle, and you can see its opposite side. Alright, you can see its opposite side. So how can we calculate that one there? Weight in x is equal to weight multiplied by sine theta. It's the opposite side. So this one is mg multiplied by sine 30 degrees. That is how we can calculate that component. The question don't say go too far, they say break it into components. It's just the drawing. Okay. Now I want to point out once more, it's like the third time, you cannot include the component in a free body diagram. You cannot include the axis. This one is intentionally done by me because I wanted you to see it and use it. But if the question asks you to draw the free body diagram, you cannot include the component of any force and also the axis. You can lose mark if you do that. Okay, so that is in terms of question 3.1. You see, now question 3.2, we answer half of it. They say calculate the component of the gravitational force exerted on the block parallel to the incline. So in other words, which one are they asking you to calculate? The x component. This one here. So let's calculate it quickly. This one is equal to m. How much is m in the question? Let's quickly have a look. I forgot. It's a 20. So it's 20 multiplied by 9,8 multiplied by the sine 30 degrees. And the rest is calculation. So the answer is 98 Newton. There we go. This is question, I said question 3.2. Question 3.2. Okay? Let's go to the next question. Next question, they say, calculate the normal force. You use the same approach in all the questions. Normal force is always on the y-axis, therefore you go into y-axis. End of the story. Okay, so this one is question 3.3. We're looking for normal force. Therefore, we are going to the y-axis. What forces do we have in the y-axis? And that is the reason why I asked you to break them into components, because I wanted you to see it. If you don't break it into components, you may not see it. In the y-axis, we have the normal and we have the perpendicular component of the weight. Do you see that? So you come here. You can use Newton's first law if you wish. I'm going to write here in y-axis. This one was done in vectors. It's an equilibrium in the y-axis. So you come here to the y-axis and you say F net is equal to 0. What forces are acting there? There is normal, positive, there is weight in the y-axis negative, and that is equal to 0. Therefore, normal is equal to weight in the y-axis. And we see there, here, how to calculate the weight in the y-axis. You see? So you take there and you substitute it here. This one is equal to mg multiplied by cos 30 degrees, and then substitute 20, 9,8 cos 30 degrees. How much do you get? So I got 169,74 Newton. There we go. Always the same approach. That is why the free body diagram with the axis is important. It helps you to understand the question, or to answer the question rather. We go here to question 3.4. Calculate the frictional force if the magnitude of the force is equal to 200 Newton. Okay? In this question you do have the acceleration. So we are going to apply Newton's second law. We don't have the coefficient of friction, so we cannot use that formula. So we're going to solve it maybe here. Let's move there. We're going to solve it there for us all. We are going to work in x-axis. I'm going to apply Newton's second law. F net is equal to ma. There is an acceleration. What forces I have in the x-axis? I'm going once more to my free body diagram and I look carefully there. What forces do you have in there for the x? That is the x-axis. There is the applied force, there is the frictional force, there is the horizontal component of weight. You can see it there. There are three forces. That's why the free body diagram very important. Okay, so we go here and now we wrote that one. We're going to write up the incline positive. Therefore, you'll have applied force minus friction minus weight in x is equal to ma. And the rest is to substitute. We have everything. How much is the applied force? It's given to us, isn't it? It's 200 Newton. Friction, we are looking for friction. Weight in x, we just calculated, it's 98. Mass of the block is 20 kilograms, and the acceleration is 2 meters per second square. The rest is calculation. So I have here now 102 minus friction is equal to 40. Is that correct?
Yes, sir.
So frictional force is equal to 40 minus 100 minus frictional force, minus 102. Are you with me? So the answer is going to be minus frictional force is equal to negative 62 Newton. So frictional force, this is the magnitude, is 62 newtons. There we go. There we go. And the last question, let me see if I find, there we go. Calculate the coefficient of friction. Now this one is very easy. For the coefficient of friction, let's do it on this side here. Let's maybe just use another color. We have that frictional force is equal to kinetic coefficient of friction multiplied by normal force. Frictional force was calculated. And normal force was also calculated. So we have friction is how much? 62. Kinetic coefficient of friction, I'm looking for it. And the normal was 169.74. Kinetic coefficient of friction is 0, how much? The answer is 0.37. No unit. The kinetic coefficient of friction do not have unit. That is the answer.